Hi, this video is meant to illustrate how we can use GIS to evaluate and analyze risk inside of a GIS. So the example here is for a solid waste management unit, and this area is for a site that we have, one of the sites in our portfolio. Here's sort of an oblique view of this site. You can see that we have some bare earth, some vegetated areas, some gravel. There's a little structure right here. And for this particular example, when evaluating risk inside of the GIS, the things that we're interested in are 5 parameters for this particular model. We're interested in the surface type. We're interested in delineated areas of VOC contamination, SVOC, PCBs, and metals. This model is really driven by decision makers and on the project team. Those folks will make appropriate decisions as to weighting factors for this model, and what we're really interested in is the intersection of all of these spatial data to be able to actually qualify statements about risk. So again, each parameter has its own weighting factor, and within that there are certain categories, be it particular surface types, ranges of values. Each of these classes, values right here, is assigned its own importance factor, a sub-weighting factor. So inside of the GIS, I've gone and digitized the surfaces here into different land use categories. And this is how it breaks down right here. The whole site is about 2.3 acres or so, and here's vegetated area, gravel area, and our bare earth area. So this is the first step for the first parameter, is to delineate the areas by surface type. These points are the sample locations that we're going to use to delineate areas for VOCs, SVOCs, PCBs, and metals. You can see that each one of these sample points has values associated with them, and then the weights that are assigned to there come directly from this table right here. We delineate areas for each analyte type using Thiessen polygon analysis, and then I then clip that just to our area of interest. Each one of those parameters are then made into a special data set that allow us to do the prioritization modeling. This is for the surface. Again, we've ranked this from low to high importance based on user input. This is our metals, PCBs, SVOCs, and VOCs. It's the intersection of all of those parameters inside of the GIS that allow us to calculate a solid waste management unit risk index. And again, that risk index is based on all of the values that the project team inputs into the model. And this is dynamic. It can be changed, and you can run various different scenarios. In this scenario, our values range from 22% to 100%. So with a GIS, we can qualify, again, any statements that we make about risk. In this analysis, we can say where the risk within the solid waste management is. We can rate that risk according to our risk index. Here we're just showing 75, 77, 80%, 100%. And within this particular case, for a 2.6 acre site, it's deemed risky, but again, we can bracket that statement by saying it's risky based on this area right here, which is 0.6 of an acre, or less than 2% of total land area. Hopefully we can use this in the future. Okay, thanks.